Okay, so if we were asked to integrate sine squared of 2x, right, which can come up in the exam, we need to be sort of slightly clever here in our approach. Remember, if you've got to integrate sine squared or cos squared, you've got to use the double angles. Okay, you've got to, right? The fact that it's 2x doesn't really make much of a difference to what you're doing. Okay, we're just going to make a slight adjustment at the end. Okay, so because I want to integrate sine squared, I got to use the middle formula. We should be happy with that. So let's just write that out now. Okay, just as I've done before. Okay, don't worry about that 2x. Honestly, don't worry about it for a minute. Okay, right? It's not an issue. But the idea is here is that we rearrange this so I get sine squared, yeah, equals. As I said, don't let that put you off. So we get sine squared. So just as I've done in the previous example, you take that over to the side, so it becomes a plus. And you take this one over this side, so it becomes a minus. So we're just swapping them. And then that 2 you take over and you divide, okay? Of course, instead of dividing, I can think of it as timesing by a half. So I get this here, okay? Now, in previous situations, right, I've then gone and straight and integrated this, yeah? Okay, right? Because we can, can't we? We can use this result here. And in a way, I'm going to do exactly the same thing again now. But this time, of course, they want me to integrate sine squared of 2x dx. Now let's compare what I've done from here to here. I changed a, haven't I? I've replaced it with this. So ask yourself what I've replaced it with. I've replaced a with 2x, haven't I? Yeah? Okay, so in a sense, I'm setting this time a to equal 2x. It's different from before, because before I simply swapped a with x, yeah, and integrated sine squared x. But now I want to integrate sine squared 2x. Just think about how I'm substituting here. A just suddenly becomes 2x. Alright? And then in my result on this side, remember now the half can go outside the integral. 1 minus, now this is the bit where we're going to be clever. We've got cos. Now that's 2a, isn't it? But remember, a became 2x, didn't it? So if I want 2a, okay, and a is 2x, I just need to have 2 of these. So in effect, then that's going to become 4x. Yeah? That's the way you should see it. Alright? Because all I've done, as I've explained here quite clearly, a you're replacing with 2x, and if a is 2x, 2a is going to be double that. So double 2x is 4x. Alright? And then we just got to integrate that. It's just like we've done before, very similar. Of course, 1 when you integrate it just becomes x. Now cos, when you integrate cos, it just becomes sine, doesn't it? So it'd be sine, this time of 4x upon then the derivative in there, which is 4, plus then c. And we're done.